Just to finish the BGP summarization series, let's see how we calculate summarization to begin with. So on, let's say, Internet 1, we have a bunch of prefixes. So if I do show run section router BGP and show IP interface brief exclude unassigned, so these subnets have been advertised in BGP as one subnet instead of four. And how did I calculate that? So this is my command. I'm advertising the lowest value in the range and with a shorter mask than 24. All the masks on those loopbacks are /24 bits. So how did I do that? Let's go back here maybe to my little tool. So I converted all those subnets, four subnets, into binary, and that's what it looks like. In order to create a summarization, we need to find what is the common number of bits that never change in all those subnets, and that is going to be our new mask. And what we do advertise is the lowest value in that range. Lowest value is 100.10.0, so the change occurs on the third byte. So if all of these are /24, this is the mask's 24 bits, which in decimal, if we convert from binary back to decimal, it's 255.255.255.0, so that's my 255, 255, 255, and 0. Now, if I want to advertise them as one prefix, those are subsequent numbers, so that makes it possible to actually advertise these four as one in the following way. I find the number of bits that don't change, so let's say this is the original mask, length 24 bits. And now value 1 here is going to be here 1. This is going to be 2. And this is going to be 3. So the third octet changes here. And we have now value 0 on the third octet. 1, 2, and 3. Now what is the number of bits that never change? So here we have 22 bits that don't change. So if I create a mask for summarization, new mask for summarization, it's going to be all those bits just like that, but these bits do change in the third octet, so I need to make them 0, and that is my summary mask, which is 22 bits, and the value is, if you convert back to decimal, 255, 255, 252.0. Now, so this is the summary mask, and we always advertise this. What we could do, in fact, we could actually take the lowest value and the highest value. Let's just remove it. And we could get the same result. So we would be looking at value 3 here, and we would see that up to this point the bits in the lowest value and the highest value don't change. Another way of doing that would be to let's go back here to look at the byte that changes and say 3 number, okay, and the lowest is 0. Largest value is 3, lowest value is 0. So if I do 3, my largest minus lowest is 3. Now, number 3 in binary, if I convert to binary, how many bits is going to occupy? Well, it's 128, 64, 32, 16, 8, 4, and 2 plus 1 is 3. So it occupies 2 bits. So this is basically the 2 bits I had to decrement from the original network mask. And now, if I want to check this here, if it's working actually, so this is, let's say I calculated and I assume it's working, but how do I know for sure it's going to be working? Well, if I go to the device that is receiving that, so let's go back here, and this is the summary route I'm receiving from Internet 1 here, /22. So if I ask my router, do you know how to reach 100.10.0.0? And it does, because it covers that 0 here, between 0 up to 3. So if I ask for 1, yes, for 2, yes, for 3, yes. Now, but if I ask, do you know how to reach the 110.4.0? which is not part of my summary, because that would be 4 minus 0. That's going to occupy 3 bits. So now if I look at the 4, it's not the part of my summary route. And how do I know that it's not? Because if I look at all those individual 110.0, it's /22, 110.1 is /22, 2 is also /22, and 3, part of my summary, is also /22, but 4 is /24. That's a completely different prefix, and this one is advertised by Internet 2 over here. So this is the one more way of verifying that my summary route is propagated properly. Obviously, I could send a ping packet to those destinations, but this actually ensures that my summary route was correctly calculated. Hope that helps.